Hey, it's Andrew Brown from Exam Pro bringing you another AWS White Paper walkthrough. And so today's white paper we're looking at is the security overview of AWS Lambda. This white paper just came out a few days ago, and I thought it was worth doing a summary on because it's such a small white paper. It only has 14 pages, and of course, the beginning and last pages generally don't have a lot of pertinent content, so it's even fewer than that. And so this one suggests that it's the focus of the security of Lambda functions. I wouldn't say it's super security heavy. I mean, if I wanted to know about Lambda security, I wish there was a little bit more in here, but there's still some good things in here that's worth highlighting. And so let's just jump into it and see what we can make of this white paper. So here we are at the start of our white paper, and we get our usual page here. We're going to scroll down, we get our fun notices, and then we have our table of contents. And you can see that it's only 14 pages in length. And as I said previously, the introduction and the remainder pages, not too much there. So it's fewer than that, okay? And then we get our abstract, we can skip through that. And let's go to our introduction, which is our first line here. And I just want to pick out what they're talking about here. So if you're looking at the introduction, most introductions to white paper, it's just a lot of sales. And so the highlights of it is that a lot of people use AWS Lambda. And they probably have a number here that says serves trillions of requests every single month. So and hundreds of thousands of AWS customers are using it. So a lot of people are using it. Another important thing is that AWS Lambda functions can handle workloads of 1,000 requests per second concurrently, right? So that means that if you have a Lambda function that processes images, you can do 1,000 per second. That's pretty impressive. And another thing, and this is pretty much the reason why AWS Lambda is considered so secure, is that because it's a serverless application, it abstracts away all the manual labor, all the DevOps that you would normally have to do. And because you don't have that layer of configuration, you don't have that control to configure what you're using under the hood, that those security concerns are just gone because there's no chance of a manual or misconfiguration that you normally would have to do, right? So if there's nothing for you to tinker with, there's no chance that it would be unsecure, and it's in the hands of AWS to make it secure. And I would think that with all their AWS engineers, that they can do a better job than I can. So that's the takeaway for the introduction. So let's move on to about AWS Lambda. What do we need to know about AWS Lambda? Well, AWS Lambda is event-driven. And to better understand what event-driven means, think of cause and consequence. Something can trigger a Lambda, and then a Lambda can output a result and tell something to do something else. So cause and consequence. So talking about how Lambdas do get triggered, Lambda can get triggered by a variety of different AWS services. And so I use AWS Lambda for all sorts of things. So let's say you insert something into a DynamoDB table. Let's say you have a sales lead and you want to then trigger that lead to do something with it on insert. Well, then you could tell DynamoDB to trigger a Lambda function. Maybe when you're processing images, you put the original image into Amazon S3 and you want to create thumbnails. And so you can have any new object put in S3, trigger a Lambda function. Maybe you need to run something on a schedule to do something on a server, like clear out temporary files or something. You could have a CloudWatch event that runs on a schedule that triggers a Lambda function that does something on your EC2 instance. So there's a lot of different things that you can do, and there's a lot of things that can trigger a Lambda function. Let's say you wanted to manually trigger a Lambda function from your code, whether it be web or mobile. I'm going to assume they're talking about the SDK here. So you can probably trigger Lambda functions definitely trigger them using the AWS SDK in your code. And so another thing is that, and this is probably, I asterisk this one because I think this is a very importance to security, and since this white paper focuses on security, is that Lambdas can be set to work within a specific VPC. So when you launch a Lambda function, it's not necessarily in any VPC, or at least not your VPC. But if you, let's say, were running an RDS database and you wanted to directly, and you're running in a private subnet, and you wanted that Lambda function to connect with it, well, you need that Lambda to be in that VPC, and you need to be able to set that Lambda to be in the same network. And you can do that with AWS Lambda. I'll show you in the next slide. And the last thing here is you can apply IAM roles to Lambdas. And I mean, that should be obvious, but the idea here is that since this is about security, that's where security is paramount in AWS Lambda, because if you give it more permissions and you have malicious code in your Lambda and it's accessing services it should not, well, that's on you. You should always make sure that you give it exactly the permissions it should to have for other AWS services. But just hopping over next here, I was saying that you can run a Lambda in your own VPC. So I just wanted to show you that option, as simple as a drop down. And now these Lambda functions will run in your VPC, and you can access resources where typically if you didn't have this in here, you wouldn't be able to access certain services. Are the benefits of AWS Lambda? There are no servers to manage. It's serverless. And so traditionally, if you wanted your code to be highly available, scalable, and durable, you'd have to use a bunch of different AWS services, which would cost money to accomplish that goal. But with AWS Lambda, it's all built in. AWS Lambda already is multi-AZ, running in a single region. It already automatically patches your OS layer and other parts of the infrastructure, so you don't have to worry about that. And it already has logging monitoring integrated with CloudWatch and CloudTrail. So we're already off to a good start. It already has scaling built in. So it says continuous scaling, right, as the second point. So remember that example previous in the introduction, or the last section here, was that AWS Lambda can run 1,000 requests per second in parallel. So that's that auto scaling in action. Sub-second metering, meaning that it bills under a second. So you pay in 100 milliseconds intervals. So that means you're going to pay less because, you know, they're not rounding up to the second or the minute or the hour, right? It's 100 milliseconds interval, and you're only paying for the execution, not for the servers running, right? So it's very inexpensive. It's extremely cost effective. The next point is very obvious, that it increases innovation because there's less DevOps, so you're free to code. And the other cool thing about Lambda is that it already comes with a community of public Lambda functions that you can run, and there are machine learning functions there that are really cool. We have an example later on in this video to show you what I'm talking about, but that's the idea of modernizing your applications, because you get to start working with cool code very easily with little effort, okay? And the last part is that it has a rich ecosystem. And so the three listed there is Serverless Application Repository, SAM, and Cloud9. I've asterisked them because I want to show you them in more detail right after this slide here. So the first one I want to show you is Service Application Repository. So when they're saying, you know, you can modernize your app and you can pull in ML, that's exactly what you can do. So the Serverless Application Repository, you just search here. I search for blur faces using recognition. And so, you know, there's integration already there. There's tons of different things in here. Like, let's say you wanted to pull data from places. Let's say you wanted to process thumbnails. There's a lot of repositories in here that you can leverage, and you can also make your own private applications. So if you have functionality that you want to share within your organization or with your clients, and you want to engineer all these little mini applications, you can do so. So that's the advantage of the Service Application Repository. SAM, some people love it, some people hate it, but SAM is a CLI and a CloudFormation macro. What is a CloudFormation macro? Well, if you've used CloudFormation, there is this command or key here called transform, and what that does is it extends CloudFormation to have more configuration that it normally wouldn't have, and it's specific to serverless, so it makes it a bit easier to work with serverless. This example, I think I pulled it straight from the docs, but it's something pretty similar to what I'm using, which is for processing thumbnails. And the CLI is a bit of a wrapper to the existing AWS CLI. So a lot of the commands would be for running CloudFormation templates, but now instead of typing AWS CFN, a bunch of stuff, you can just type the word SAM. Okay, and the last one, which is a very important one, is Cloud9 integration with Lambda. It makes working with Lambda so much easier. When you have a Lambda function of a certain size, you're no longer able to edit it in the console, but you can edit it over here. So this is the frustration, is that when you start working with all these dependencies, you lose that agility that you normally would. But Cloud9 allows you to do it because over here you can see I have a bunch of remote functions. And with the press of a button, I can import it into my IDE, Cloud9, right? Work on that code. And then when I'm happy with it, I press the button, it goes back and deploys it. So it's a much easier way to deploy, and it makes working with Lambda so much easier. I strongly recommend checking out Cloud9 integration with Lambda. You'll find it very pleasant to work with. So what's the cost of running Lambda functions? It's extremely inexpensive. So you pay as you go, and there's two ways that you pay. You pay for how many functions you run, and you pay for the time it takes for a function to run. So let's look at the first one here. So you don't pay for the first 1 million requests thereafter. So see down here, it says 1 million free requests per month. So if you are a very small startup, you can find that Lambda basically is free because you'd have to go through 1 million in a month before you'd have to pay that 20 cents per request. So it's going to take a while before you even hit that. And then you can see, as I said, it's 100 milliseconds intervals. And this is based on the pricing of the memory. So if we go over here and just go down here and look at the pricing here, you can see as the memory goes up, the price goes up per 100 milliseconds. But you can see the numbers are extremely small. So, you're going to be paying next to nothing on AWS Lambda. So that is how pricing works on AWS Lambda. It's always hard to avoid is the shared responsibility model, this big, ugly diagram, but it's very important in terms of security, especially with AWS. If you're getting certified, you'll come across it in every single exam. You need to know it. But let's cover it quickly here and try to understand the context in AWS Lambda. So what's most important is understanding of the cloud and in the cloud. So when we're saying of the cloud, we're saying what is AWS responsibilities in terms of security. And then when we're talking about in the cloud, we're talking about you, as in what are you responsible for? So AWS is responsible for the underlying infrastructure, the operating system, and the application platform. So I'm guessing in this case, it's the services, right? So AWS Lambda, or SQS, whatever. That's what they're talking about. They're responsible to make sure they're secure and everything is working as expected. In this case, AWS is doing a lot more work because since serverless means that you don't touch as much stuff as you normally would, it's more on AWS to make sure things are secure. But let's talk about what you can secure and what you are responsible in AWS Lambda, securing your code. So if you upload code to AWS Lambda, make sure that there's nothing malicious in there, especially if you're using Node.js. There are so many plugins that it's very easy for something to slip its way in there. In some companies, and I think AWS actually does this, is that like for Node.js, you have to get packages approved internally before you can use them, or they'll end up writing their own packages just to make sure there's nothing suspicious in those packages. So that's one way you can secure your code. Then there's accessing the storage of data. So data could persist in the memory to some degree. So maybe you want to make sure that you ensure that that data is scrubbed. We'll talk about that later on because we do talk about memory scrubbing in AWS Lambda. But another thing is like, let's say you need certain credentials in your code. Well, don't code them into your code directly because AWS Lambda allows you to slot them into environment variables so it passes it along. Or let's say you needed to pull credentials from S3. Well, make sure that the credentials on S3 are encrypted and only the people that are allowed to access it are allowed to access it. So that would be the case around sensitive data. And another thing is IAM roles. This is obvious, but I'm going to repeat it again, is that you can attach IAM roles to AWS Lambda functions, but only give it permissions for what it needs, because we come back to the case of if you had malicious code in here, let's say there's malicious code that wanted to take advantage of some AWS resource, and you've given this Lambda function full reign because you didn't narrow down the permissions it's allowed to have, well, that's where you're going to have a bad day. So that's the coverage of the shared responsibility model with AWS in the context of AWS Lambda. Looking at the Lambda runtime environments, there's two types of planes in Lambda runtime. There's control plane and data plane, and the control plane is it's responsible for the management of APIs and the management of integrations. The data plane is responsible for the running of functions and choosing the environment the functions run in. If you ask me, what is a plane and what is this stuff? Honestly, I could not tell you. I'm just telling you it's from the document, so I extracted it out here to make it easily to read. But for me, this is a little bit too much for me to think about. If I don't know it, I don't think you should have to worry about it either. But the other part that's really important in this section is Lambda's running a micro VM. So VM, virtual machine, micro, a very small virtual machine that's running on hardware. So micro VMs run on Lambda workers. Lambda's workers is a fancy word for dedicated managed hardware that runs, here it is, AWS owned and managed hardware platform, Lambda workers. So you can't ever touch those things, but that's what they call it internally, or at least they tell us that's what it's called. And then the execution of these environments are never shared across functions. So if you have a function for processing thumbnails, only an environment is spun up, it will only run the function for processing thumbnails in that environment. So it's isolate to functions. You're not going to have functions that can run across multiple environments that are spun up. Okay. And micro VMs are never shared across AWS accounts. Never, never, ever, ever. So it's isolate to your specific account. And we'll get more in depth in the next slide about isolation. The isolation of functions obviously plays a very strong role for AWS Lambda, and so understanding them is kind of important. So let's look at an execution environment. And so an execution environment is made of the four following things. It's the code that you run, the functional code. You have Lambda layers, which is a fancy way of saying a zip file that contains libraries, custom runtimes, or other dependencies. So a few cases is like, let's say you're using Node.js and you have a bunch of libraries that you want to utilize in Node modules. You put them in a zip and upload them. That's Lambda layers. Or here's an example is like, let's say you wanted to use PDFTK, which is a way of extracting form data in and out of PDFs. And it is a specific binary that you want to bundle onto the instance. Well, you put it in the zip with your code, and that is a Lambda layer. So that's what Lambda's layer. And when you see Lambda layers, just think of code that you put in a zip with dependencies. Then you have your function runtime. So your runtime is the language you're using, whether it's Python, Java, Node, etc. We'll list them all later on. And Amazon Linux, the actual OS that it's running on. I think all Lambdas run on Amazon Linux. I don't know if they run on anything else, but they run on Amazon Linux. And so the environments are isolated in two ways. They have technology because from Linux. So here they list them out like C groups, namespaces, IP tables, routing tables, chroot. If you want to know more, read through this section. But the idea is that there's a bunch of Linux tools that they use to keep things separate. And then AWS has proprietary isolation technology. I wasn't sure if they're talking about Firecracker because Firecracker is open source here, but they do make mention of Firecracker. Down here they say AWS uses two different mechanisms for isolating micro VMs, EC2 instances and Firecracker. And Firecracker has a very beautiful website. Go check them out, and maybe that will help you contextualize what they're talking about here. So looking at storage and state, they should have called it state and storage because the first thing they talk about is the state. But in the previous slide, we were talking about the execution environment. And let's talk about the state around the execution environment and how we can reuse it to gain performance with our Lambda functions. So one of the biggest pains of Lambda functions is that they can be slow to start for the first time. But when a function runs again in the same environment, it's fast because it's already running. So Lambda functions have reusability when you're invoking the same function on the existing environment. And so that environment, like if you run a function, it doesn't spin the environment down right away. It'll stay running for a little bit to see if other functions may get triggered. And if it does, it says, okay, you reuse this environment. And that could go on for a few hours. There's probably like a cap where they say, okay, you ran enough, let's kill it and start a new one. But yeah, you could see an environment running for hours if it has something to run. And moving on to the storage component, let's say you needed to write temporary files to Lambda. So let's say you had an image. So like you download an image from S3 and you want to create a thumbnail. Well, you can throw that image, pull it from S3 and store it in your temp directory on that environment. The temp directory is destroyed when the environment stops running. So you don't have to worry about those files. And that temp directory can either be backed by EBS or instance storage. I didn't really understand that because I believe that generally it's local storage. I tried to do a bit of a Google or look at the docs how EBS works on there. But anyway, it says that they work with both. I'm not sure how it works with EBS. Anyway, I think that temp is instant storage. But the point is that you have a place where you can write temporary files and you don't have to worry about them. If you are worried about data that's in memory, when a Lambda function, before it's reassigned, AWS will scrub the memory of that instance. So you don't have to worry about other people abusing data that was in memory. It does not scrub memory on the reuse of the same function in the same environment. So let's say an environment is spun up and you have queued in it 5 thumbnails. They're going to share the same memory until that environment spins down. And the last thing is that let's say you have some very stringent security requirements. You have to make sure that that memory is encrypted, or you have to ensure that it's wiped well. There is some way to do it. I think there's like a termination script or something that you can do, so that you can definitely ensure there isn't any vulnerabilities in the memory. So that's storage and state for us. So now we have this big section here on invoke data path. It's a really convoluted way to tell you that there's just 2 ways of invoking AWS, and we already know this from the first slide, but let's just talk about it in more detail here. So when you have a Lambda function, you can invoke it, you can trigger it basically in 2 different ways: request response mode and an event mode. So when we're talking about request response mode, we're going to be thinking API, gateway, or SDK. So the idea is that this is when you're triggering it like for a web application, basically, or a serverless web application. And the expectation is you're sending it a request, a web request, and you're expecting a web response, okay? So I'm just trying to think of an example. Let's say you have a contact form and that contact form hits API gateway because it takes a request. And so that request comes into the AWS Lambda function, and that Lambda function does something with it, and then it sends back a JSON response so that on your website it can display something. So that is one method of doing it, but here they go into the guts of it, saying it goes through API caller, and when they say API caller, they just mean API gateway or SDK. That says there's a load balancer, which we don't have to think about. It goes to invoke service, so that means it just triggers the Lambda function. It goes to the execution environment and it runs it. So a little bit complicated for a very simple explanation. And then event mode, it just means when some service on AWS triggers it. So it can execute now or schedule for later. When it's saying schedule for later, it just means that the thing that is going to trigger it is going to be a queuing service like SQS or CloudWatch events, which are all delayed, right? Say due later. But you can invoke it from multiple AWS services: SQS, CloudWatch, SNS, DynamoDB, Kinesis, and a host of others. So that's invoke data path. So now we're looking at the runtime maintenance of Lambda. So AWS Lambda can run a variety of runtimes that it supports. That means that it keeps them up to date. And we have Java, Python, Ruby, Go, Node, .NET, which can also do PowerShell with one specific version. And there's custom, I don't know if custom, it's supported in the sense that you can set up whatever you want, but I don't know if it would do, I guess it would patch certain things here. But like when we say custom, let's say you wanted to run Elixir or Erlang, which are 2 really cool languages. There is some way to do it. I haven't personally done it myself, but I've been very eager to try it. But if you want to run anything on here, any language that you want, if you have the elbow grease, you can do it. But anyway, if you want to just get going, you can use any one of these already supported languages out of the gates. And so Lambda, so AWS provides support automatically, so they automatically apply updates and security patches, and they say other maintenance. What that is, I don't know, but they do something, it's good. There is an exception where they say that this isn't always an automatic process because sometimes it requires a manual confirmation. So sometimes there's a reason for it. It's like they're testing out patches before they deploy, and so it'll show up in your personal health dashboard, which is kind of like a way of telling you about alerts regarding services, right? And then you might have to approve it manually, but for the most part, it's automatic. And then there's this thing about deprecating runtime. So this actually happened recently where like a 6.1 or 6.10, I always say 6.1, it's actually 6.10. I don't know. And I made a video recently where I said 6.1. People are going to look at me and say, why'd you say that? But sometimes the community marks them as end of life. And so AWS, in step with the community, decides that, okay, we're going to encourage people to stop using this. And so if you have functions that are running on 6.10, you can no longer create new functions on it. You can still run your old ones, but we're going to disable the ability to make new ones. And we're not going to provide all the support around it. So if you're going to run them, it's at your risk. And I don't know if they like eventually disable it so you can't, but I got an email recently where they're saying like, hey, start upgrading. So there is that little bit of frustration where you're kind of forced to update, but the idea is that you're supposed to stay secure, right? Because you can't run old stuff forever. So that's them forcing good security practices on you. AWS wants you to consider the 4 following AWS services when you're monitoring your Lambda functions. You have CloudWatch, CloudTrail, X-Ray Config. Looking at CloudWatch, it automatically already monitors Lambda functions and collects CloudWatch metrics on them. The 3 being that I pulled out from the documentation, the most important ones probably are invocations, errors, and durations. So if you have a lot of functions that are erroring out, that metric can count up and you can make an alarm and say, hey, after something fails 10 times, tell me about it. That would be pretty darn useful. Or maybe you want to know the average runtime of your, like the duration. I shouldn't say runtime because that's a confusing term when we're talking, because we just saw runtime in the last one. But if we're talking about how, like, the average duration of a function, this would be valuable to do. CloudTrail would show you whether it was triggered by the SDK or the API. So if you needed to blame somebody, CloudTrail is going to be very useful for determining that. X-Ray is good when it's interconnected with other services and Lambda functions because, debugging one function is one thing, but when things are tied to different things, it becomes a lot more difficult to determine stuff. So X-Ray gives you that holistic view on figuring out where problems lie, like the root cause of problems and stuff like that. A very interesting service. And if you're really into serverless, definitely something you're going to be using day to day. AWS config. So let's say you had a Lambda function and you have a junior on your team and they deleted a Lambda function that was critical to your infrastructure or your operations. And you want to know if that happens. So you can make a config that's going to tell you, did someone delete a Lambda? Did someone delete this specific Lambda? And so that's a very useful tool. I'd be curious to know if the way it checks is through another, because AWS config uses Lambdas to check stuff. So it's like you're using Lambdas to check your Lambdas. That's very meta, which I think is pretty cool. When we're looking at the architecture and operation of Lambda functions, to help you understand the best practices, they suggest to look at the Serverless Application Lens white paper, and then they point you towards the Well-Architected Framework white paper. If you have not read the Well-Architected Framework white paper, it's the most important white paper to read in AWS because it appears in all the AWS exams. And then each of these pillars has its own white paper that you can read through. So there's a lot to chore your way through, but they're definitely very important to read. It's interesting they only list 4 of the 5 pillars. I don't know what happened to cost optimization. And I got a spelling mistake in there, but that's okay. But they're pretty self-explanatory. So one's about operational excellence, security, reliability, performance efficiency, and cost optimization. They all have their own white papers. So this is just AWS saying, go read more white papers if you want to know more. Okay, we're on the last part of the white paper, and it's about compliancy with Lambda. And so the first thing that they point out is that AWS cannot advise customers on your use case, only give them general advice. So they say you can contact AWS experts, solution architects, domain experts, technical account managers, and other human resources for assistance to determine your compliancy needs, but we can't tell you what you should do. We can just give you general advice. Okay, and so that's AWS saying, we don't want to get in trouble, right? So that makes sense, but they'll help you the best they can. And then they go on to list, as of March 2019, Lambda is compliant with the following things. So SOC 1 to 3, PCI DSS, and HIPAA, which is the Health Insurance something Accountability Act. That's in the States. I'm in Canada, so I never remember the whole word, but I know what HIPAA is. And then they say, like, if you want to see that we are compliant, you want to see these compliancy reports, you can't just download them. You have to go through AWS Artifact, which is an application to securely download these reports for your review. So if you are ever working with enterprises and they say, is AWS compliant with HIPAA? They say yes, and they say prove it. Then you go, okay, great. You go to AWS Artifact, you download AWS Artifact, and you have to click through a few things, and you can get that report to prove it to your enterprise. So yeah, that is the compliancy section. Let's wrap off and let's just check out what's down below here. They have a conclusion, not worth reading. Here's the wonderful contributors to this white paper. So good kudos on you for putting this together. And then they have further reading where they're just repeating, serverless application lens we saw earlier and a few other ones. And that's the end of the white paper. And they got the appendix on firecrackers, which there's not much to say here, but we did it. We made it to the end of the white paper. Thanks for sticking to the end here. And, if there's a white paper that I have yet to do that you're really interested in and you want to see it posted online, just reach out and tell me and I will go do it up.